Hello everyone, and welcome to the Hidden Secrets channel. Tonight, we're going on a journey deep into Earth's ancient past to discover how something that was once alive can slowly become part of a stone. Millions of years ago, animals walked across landscapes that no longer exist. Some died, were buried beneath layers of sediment, and over immense stretches of time, their remains or traces were preserved inside rock. But how does this actually happen? How can bones, shells, footprints, or even trees become fossils? Tonight, we're going to uncover the science behind one of nature's most fascinating processes: how stones become fossils. Let's begin. What if I told you that some of the rocks beneath your feet are not simply rocks? Some contain the remains, or even the traces of life that existed millions of years ago. But there is an important mystery here. How does something that was once alive become part of a stone? The answer is a slow process called fossilization, and it begins long before a fossil ever looks like a rock. Imagine an ancient animal living beside a river millions of years ago. When it dies, its body does not automatically become a fossil. In fact, the opposite is much more likely. Scavengers, bacteria, weather, and natural decay can destroy most remains before they are preserved. For fossilization to have a chance, the remains usually need to be buried relatively quickly beneath sediment, such as mud, sand, or silt. Rapid burial protects the remains from some of the processes that would otherwise destroy them. Organisms with hard parts, such as bones, teeth, shells, or woody material, also have a better chance of leaving a fossil record than organisms made mostly of soft tissue. Now imagine layer after layer of sediment accumulating above those remains. A little more mud than sand. Then another layer. Over enormous periods of time, the pressure from these sediments increases. The loose material gradually becomes sedimentary rock. What was once a living environment is slowly transformed into a geological record of the past. But the remains themselves can change too. Groundwater moving through the buried material may carry dissolved minerals. These minerals can enter tiny spaces within bones or wood. This process is called permineralization. In other cases, the original material is gradually dissolved and replaced by minerals. This is called replacement. The result can be something remarkable. The original structure of the organism may be preserved even though much of its original material is gone. And this is where the word petrified can be misleading. Not every fossil becomes a solid stone copy of the original organism. Some fossils are molds or casts. Suppose a shell becomes buried in soft sediment. If the shell later disappears, it can leave behind a cavity, a three-dimensional impression of the shell. Later, minerals or sediment may fill that space. The result is a cast, a geological record of the shape that once existed there. Other fossils can be much simpler. A footprint pressed into wet sediment can harden and eventually become part of the rock. The animal itself may disappear completely, but its movement remains recorded in stone. These are called trace fossils because they preserve evidence of an organism's activity rather than its body itself. There is another fascinating example: petrified wood. A fallen tree can become buried beneath sediment. As mineral-rich water moves through the buried wood, minerals can fill its microscopic spaces and, in some cases, replace the original material millions of years later. The object may look like a piece of ordinary wood, but chemically and physically, it has undergone a remarkable transformation. Its rings and original structure can sometimes remain recognizable even though the material has become mineralized. But fossilization is extremely rare. Earth has been home to an enormous number of organisms throughout its history, yet only a tiny fraction are preserved as fossils. The fossil record is therefore not a complete recording of everything that ever lived. It is more like a collection of surviving pages from an unimaginably large book, and those pages are usually found in places where sediment accumulated. Ancient seas, lakes, rivers, floodplains, coastal environments, and other sediment-rich landscapes have produced many of the fossils. Scientists study today, so the next time you see a strange shape inside a rock, remember what you may actually be looking at. It might not simply be a pattern in stone. It could be the preserved evidence of an organism that lived in a completely different world when continents looked different, climates were different, and species existed that have been gone for millions of years. A fossil is therefore more than an old object. It is a message from deep time. A footprint can tell us that an animal once walked across ancient ground. A shell can reveal what lived in an ancient sea. A piece of fossil wood can preserve the structure of a tree that existed long before humans appeared. And a bone can give scientists clues about an animal that disappeared long before anyone could ever see it alive. The most remarkable part is that nature does not create these records intentionally. There is no guarantee that a dead organism will become a fossil. It requires the right combination of burial chemistry, sediment, time, and geological conditions. And when those conditions come together, something extraordinary happens. Life becomes part of stone. Millions of years pass. Mountains rise. Rivers move. Seas disappear. Rock layers are buried and later exposed again. Eventually, a scientist, or simply a curious person, may find a fragment of that ancient record, and suddenly, the stone is no longer silent. It begins to tell a story that started millions of years ago and somehow survived long enough for us to hear it today. That is how fossils become part of the rocks, and how rocks become one of Earth's greatest archives of ancient life.